Hello, and welcome again back to another episode of Making Cool Stuff in Blender. And today I thought I'd like to do something a little bit more themed than usual. I thought about what could I do in terms of interesting rock work, and the most unusual and interesting type of rock work that comes to mind is the one that Land used for Taron, and that is basalt pillars. Now, both do appear in nature. They look slightly different than what they did with Taron. But either way, it looks great, and let's attempt to recreate exactly that. So we don't need any of this in Blender right here. Well, we do need something, but we do need some kind of mesh. It does not need to be the cube. It could be anything else. I just like the cube, and also deleting the default cube and adding it back in is also kind of a Blender inside joke. So big funny happened right there. All right. So how do we start? We start the same way as always. We add a geometry nodes modifier. Simply because, of course, this is going to be made with geometry nodes. So I added the modifier, and let's go into the geometry nodes workspace. So what I have in mind for this is I would like to make a wall of basalt pillars, and I want to make that wall based around a curve that I can draw at the bottom. So the idea is to use a curve, but this could also be a coaster track spline or whatever. If you want to make basalt rocks that are next to the coaster track, but let's just use this for now. So we drag this in here and connect to the output. So that goes away because the way geometry nodes works is you have inputs and you have the output. And the geometry input is what we had before, so the base object or whatever the object looked like if we had any modifiers above the geometry nodes modifier, but we don't. So what's going into, or what's coming from this input here is just the cube. Since we don't need this connection, the cube is going away, and we have the spline instead. Now, to turn the spline into a wall, we can use curve to mesh. At first, this doesn't appear to do anything, but this curve is now turned into a mesh. You can see we have vertices right here, and before we didn't have any, but we had a spline, and now if we connect this back in, that spline goes away. So this is now a mesh. That isn't really too helpful just yet, because to turn it into a wall, which is what we want to do in the end, we need another curve to use as a profile. And that can be any curve, basically. Let's just use a line for now. And as you can see, it does something. It's not quite what we want just yet. So the Z direction seems to be the wrong direction, but the Y direction seems to be correct. So we want to go upwards. So let's decrease the end. Maybe make it like 15 meters and oops, yeah. Didn't I just say that it needs to be negative? This looks correct. All right, so now we have a wall. But if we go into the wireframe view, we can see that it's just made of really long individual faces. I don't think this is ideal, because what I think is what we should do is to make this look more natural than just a straight vertical wall, we should give it some deformation. And you can only achieve deformation by displacing points. And if we just have like a row of points at the top and one at the bottom, we can displace both, but we can't do anything in between. So let's add more, and we can do that by resampling the curves. So we can resample the curve line, which already does what I want. However, I think we should also resample the initial spline to make this as even as possible. Now, it may look even now, as if these were squares. Well, you can tell that they aren't squares, but it's closer. But that is just a coincidence. If I make this spline right here a lot bigger, you will see that these stay like they stay the same. The amount of points don't increase, and that's not ideal. To make the displacement look as good as it can, we need to have it. We need an even density of points. So what we can do, instead of just picking a fixed count, we can pick a length. And the default is 0.1 meters for some reason. And as you can see, that makes a really dense amount of, like, the density of the points is really big. So let's maybe increase it to 1 meter and do the same here. And now you can see these are pretty square looking. All right, next up, we can displace these points. And we can do that with set position and an offset. So if I enter something in the offset here, it offsets the whole thing. We don't want that. Instead, we want the offset to be different for every point, but also not entirely random. And the perfect thing for exactly doing that is a noise texture, because a noise texture basically generates a random value between 0 and 1. But it's not entirely random, as it has some sort of gradient between points based on how far they are apart. It's a bit hard to explain just with words, so let me visualize what I mean. If we take a vector scale node and use a normal node for the vector, we can displace all the points in the normal direction. So the normal apparently goes in this direction. And as you can see, it's evenly spaced away from the original spline. By what exactly? By a scale of 1, and since the normal vector is always 1 meter long, this offset is exactly 1 meter. You can also tell it here nicely with the grid. Now, if we use the factor of a noise texture and plug that into the scale, then it picks a different scale for each point. So let's visualize that. Oops. This is already showing different displacement. This, you can see it like on a sharper angle. But we can make it more extreme by multiplying with another vector. And as you can see, now it gets more and more extreme. But also, by the looks of things, it still seems pretty random. And that's because the scale is really high. If you turn the scale down here, you can see it's flickering a lot. And if we just pick like 0.2 or 0.3, it's much better. However, what I'm a bit surprised about is why this right side is so similar. Huh. So regardless of what I enter here, the right side seems pretty similar, and that does not make too much sense to me right now. But we'll see. What we also should do is, since this produces values between 0 and 1, we should subtract 0.5. And that makes it so that the thing is still centered around the original spline, instead of just being always offset from it. So some points go inwards and some go outwards. And I think that maybe fixed some other problems as well. If I increase this now, yeah, that looks pretty good, I think. Yeah, let's maybe put 6 here, and maybe let's change this to be the same first of all, and maybe make that a parameter here as well. In the modifier window itself, and let's maybe make this smaller, so like it's 0.5, so it's a bit more dense. And then we can see, all right, the scale is still way too high. Let's change this back, and now you can also see how what I first said applies now, that the further we scale it down, that the more similar values are picked for points that are close by. I think this looks good in terms of deformation on the wall. So let's stay with that for now. Now next up, we need a way to place the basalt pillars on here, because this is not the end result, this is just like a thing we can stick them onto. So what we should do is we should place points on the surface of this thing so that we have something we can use as positions for the pillars. So for that we can use a point distribute points on faces node. And to visualize what is going on, let's put the joint geometry so we can see both at the same time. And this node just randomly distributes points on the faces, and that's all nice and well. However, if we think about how big the basalt pillars are, this is pretty dense, imagining that each point is one basalt pillar. So that's not quite what we want in terms of end result. There are two distribution methods for the points on faces node. One is random, and then one is Poisson disk. And I don't know why it's called this, but the cool thing about it is that you can pick minimum distance between the points. And if we pick like 1 meter, we get much more even spacing without it being too uniform. And I think that's great. And now we can place pillars. And to make the pillars, I would say we should use a primitive cylinder. And to place them, we need to use instance on points. So we use the points for the points, and the instances get joined with the wall. And now we can plug the mesh into the instance. And now we get a bunch of cylinders. Well, those are way too round. Let's pick 6 sides. Let's make them less big. Use like 0.5 meter in terms of thickness, and maybe make this longer, maybe like 5 meters. Now this is already quite nice, I think. However, it would be even nicer if they would turn so that they face, so that they align themselves with the wall. And I think we can do that by using the align Euler to vector node. And I hope this works the way I want. In my head, we can just use the normal from the point, plug it into the vector, and plug the rotation right here into the rotation of the instances. That did not quite do what I wanted. This isn't it either. This looks more like it. So this is about what I wanted, for now at least. Maybe let's make these even smaller. So not because they need to be smaller, but because this allows us to better visualize what's going on. So as you can see, what I initially wanted to do works, so that each pillar is now rotated to fit the wall, to align with the wall in the point that it's placed on, but it's really jagged. So the wall on Taron isn't this bumpy, let's say. So let's make it less bumpy. We can just scale this down to just make them turn less. And maybe we can also increase the distance between the resampled points, so there is less detailed variation in the deformation of a wall. Maybe let's scale this up a bit more again. Yeah. So this is quite boring still, because what happens on Taron is the pillars don't only align to the wall, they also like flow around the wall. It's a bit hard to explain. And this is something that might be a bit more complicated than what we had before. So in my head, we can use another curve. So let's make one. And let's make it really big. And in my head, we can do, something like this maybe. So my idea is that depending on how close a pillar is to this curve, the more it, or rather that it, how do I word this? My idea is that the pillars align to this curve. That's basically it. So they say align to the wall, but they also rotate around another axis to fit the tangent of the curve. So Let's try that. Let's get this second curve and place it in here. And how do I do this? Let's convert this curve to points. The reason we need to convert it to points is because to find out what pillar or how far a pillar needs to be turned in whatever direction, it needs to know the tangent of the closest point on the curve. And what you can do is you can sample a curve at any point based on the distance from its curve, from the end of the curve. And that is all fine and well. However, you can't do the opposite. You can't find what is the value on the point of the curve that is closest to this other point in space. And what we can do instead is we can just convert the curve into a bunch of points and then find the closest of these points. So we can just plug this into the curve and then rotate the instances. And don't plug the rotate instance there. It needs to go here because after we join geometry, we also include the original wall mesh, and that's not really that helpful. So it just doesn't work with rotate instances. That's why we got this information symbol here. Realized data and input geometry is ignored. And realized data is everything that is not an instance. So we can just use another one of these. And now I'm wondering what happens. Nothing happens. And that's because I think the reason nothing happens is because the pillars don't know what tangent to look at. So we don't really do anything. So what we can do instead is sample and get the index of the and get the sample nearest and get the nearest point. And then we know the index of that point, and then we can sample an index. So we plug the index into the index, and we also get the points from here. And what we want to sample is not a float value, it's a vector, and it's the normal of that point. Or was it the tangent? No, it was the tangent. And now I think this should do something. It does. Interesting. This does what I want, except it goes into the opposite direction, which is interesting. Why does it do that? Huh. So we want to take essentially do this. But why is it going the other direction? Do I need to use the normal instead of the tangent? And now I use I am really confused. Why does this not work the way I want? There's always some confusion to me about what exactly this node does and how it, like, how it basically uses a vector and gets a rotation out of it, and what these settings do. So I just click around until I get what I wanted. Can I just use this instead? Why is this going the opposite direction? If I edit this now, what is happening then? I'd be lying if I said I wasn't confused right now. This is all a bit odd, to be honest. What is also a bit surprising to me is that sometimes some pillars don't react to the points at all, and the reason this is weird to me is because they should always sample the point that is closest to them, that is generated by this curve. I don't think there's much point to playing around this with this more. So I think I'm just going to continue with what I wanted to do anyways. Yeah, so you can see it also working when you take multiple curves. Let's also maybe make these a bit shorter. Maybe 4 meters is better. Yeah, maybe. Okay. Maybe we can also do more interesting things with the pillars themselves. So if we take a look at what each pillar looks like, we can just look at this one specific pillar. If we just plug the mesh into the output, so all the rest gets ignored for now. And now we can just make this look a bit nicer. So what I would like to do is to basically steal this setup here and deform the cylinder a bit. But maybe that is something I can do at the end as well. So let's keep this in mind. What I also would like to do is to give it more segments. No, those are segments at the top. I want side segments. And the idea what I am doing right now is more or less the same I had with the wall, because I want to deform these pillars slightly to give them a bit more of a natural, less perfect look. And to achieve that, we need more geometry, of course. I could also use these other fill segments at the top and bottom to make the top a bit more rounded off, I would say. Let's see, can I extrude? I can steal this again for that purpose. Can I extrude these outwards a bit? And if I just use the top, all the points that belong to the top side get scaled. If I just use the side. Interesting. So these points here belong both to the top and the side. It is good, because that means I can just use some Boolean math. And I want to use the top. And what is not the side. And that allows me to just isolate this center face. But I also want to do the same to the bottom. So I can duplicate this end, use this again here, and use this for the bottom. And now I can use an OR here. So either of these now should work like that. Let's maybe collapse these so it's not that busy in this part of the node network. Let's maybe let's do this. All right. So this looks quite nice, I would say. We can now put this into the instances and this to the output. And now we have these slightly rounded off pillars. And now we can deform them further. Oh yeah, I was just a bit confused because now the pillars didn't move. But actually, I think I don't want this thing down here to affect the wall and the pillars. I just wanted to affect the pillars. And to make it affect the pillars, I need to realize instances. And I can also steal this from here. I need this as well. Can plug this in here. And this is completely awful looking. Let's change it to like 0.5 meter. And let's make this scale much bigger. Let's not make it this big. Also, maybe... what if I plug the color directly in here? No, that looks awful. I think these now look a bit short. Let's make them a bit longer again. What if I make them like 6 meters long? And what if, like, I decreased the length because this looked a bit too busy. But what I can do is just decrease this further. So let's set it to 1.5. And honestly, maybe 1.5 is a bit much. It's maybe like 1.3, 0.2. I think 1.2 works really well. Now let's make this part of a wall a bit bigger. Let's see what this looks like. I think this looks really cool. And we can control it a bit with these curves. And yeah, I think that makes it really Taron-like looking. I'm sure you can do a lot more. Like you can also give this a material and make that nice and all that. Might do that actually. Yeah, it's not that long yet, the video. So let's go into the shading tab and let's add a texture. I recently downloaded something nice that would be cool for this, I think. And that is this texture right here, and it does not appear on our model, even though we added the material to the cube. Let's call this basalt, and let's spell it correctly as well. The reason it does not apply to the pillars yet is because we need to tell geometry nodes to do so. What did we call this? We didn't call it anything. Let's also call this basalt. Let's go to the material preview and we can see that it's single color. And that's because we don't have a UV map for this. So let's make one. And we can do that procedurally by storing an attribute and giving it the same settings that a UV map would. And a UV map is a 2D vector in the face corner domain. And let's also just call this UV map. And if we now change these values, you can see that it starts to flicker. And that's because all the points, or rather all the face corners, the difference between the face corner and the point isn't important right now. I might explain that another time. But the idea is that we have an image, and these values tell all the points of the object where to look on the image for sampling that part of the image's color. And right now we are plugging in zeros for the entirety of the object. So every point is sampling the exact same point on the image. So everything is the same color. And we can change what it samples here by making it based off the position in the point has in the world. And we can do that by reading the position of each point and plugging that in here. And that shows you, oh, awesome, we now have a texture applied to this. And we do, but it's really ugly. And we can make it look better by, first of all, controlling what part of the position is used to make the UV map and how it is translated to the UV map. So if we now look from the front, or from the front is relative to the wall, in this case the y-axis, we can see that the way I have plugged it in right here is that it reads the x-coordinate and passes that through, and it does nothing with the y. And that's because, for that reason, we get these stripes that perfectly align with the, that are perfectly vertical. And that's because it uses the left to right, so the x, to sample the texture. So they have a difference in this direction, but they have no difference vertically. And that's because we need to make the texture display properly. We need like the left to right, and we need the up to down, and use that for the texture. So left to right is the x, we already can see that, and up and down is the z. We can see this here. So we need to plug the z into the y, because if you think about it, on the texture, the x is side to side, and the y is up and down. So this does exactly what we want. However, we have a lot of repetition, and we can fix that by stealing a scale right here and making this really low, like 0.1 maybe. Maybe not 0.1, maybe like 3. I think this looks much better already. However, this only really works when the wall is oriented on the x-axis. If I do this right now and make it go like this, and we look at it from here, you can see this is really ugly again. So what is going on here? It is not aligning nicely to the wall by any means. Looks like there are a bit more shenanigans going on than I initially thought. Huh. Maybe there are some things that need to be fixed with this curve setup. Maybe that didn't quite work the way I thought it would. But regardless of how these pillars are oriented right now, we need to fix this stretching right here. And we can fix it by looking at each face's normal. And depending on the normal, we can make changes to this, like what gets passed through from the position to the UV. So let's duplicate this, and let's add in a switch, And the switch does exactly what we need. It switches between two different things. Like so. And once again, we want to use the Z for the vertical, but now we want to use the Y for the X because we want to fix these areas here. And if I now activate the switch, the bottom input that is set, that is the true input. So this gets passed through if this checkbox is set to true. And now we can see it looks much better. However, we still get a lot of stretching in other parts. And that is also not quite what we want, but we can make with the switch not based on a single yes or no, we can decide independently per phase. So we need to check what normal, what direction of the phase is, or what direction is the phase pointing most, I would say. And we can do this by using math and looking at the and using a greater than, and can look at is the y greater than the x, so is the value greater than the threshold. And if that's the case, it switches. And it seems to work fine here, but it does not work fine here. And you may wonder why. And either it's a coincidence and I didn't think what greater than or less than actually, or if x is greater than y, then this is pass-throughs, and I'm not sure if this is actually what we want to pass through in that case. But regardless, something else we also need to take into account is that x and y can also be negative. So we might say, oh yeah, this phase right here is obviously pointing more in the y direction, so we would want this to be used. No, it's pointing in the y direction, so we want this to be used. Yeah, and not this one. And what it does right now is it looks at, is x greater than y? X isn't greater than y in this case because the face is pointing in this direction. And it should say false and then pass this through, but it doesn't. And the question is why? And that's because while it does obviously point in this direction, it also slightly points in this direction, and this is positive x and this is negative y. And positive x obviously always bigger than negative y. And so that means like a really small positive x is indeed greater than a large negative y. So this is passed through, even though we don't want that. And I talked a lot about that topic now, and I can show you what we need to do instead of just comparing the raw values as is. We need to remove the positive and negative aspect, and we can do that by using an absolute. And we use that on both the x and the y, and suddenly everything is looking the way it should, except this jumbled mess over here. Yeah, maybe I can fix that another time, because I'm afraid that I have run out of time for today. So what you would do after this is you would export it and import the model into no limits, give it the materials with same textures as you did for the model, and that would be that. It should work with the UV map, because this actually stars a UV map. This is more or less a new thing since Blender 3.6. Previous versions of Blender couldn't just store UV maps with geometry nodes. That was really annoying. And so this is much nicer nowadays than it was like half a year ago. All right. I hope this was nice and interesting and helped making interesting Taron-inspired rock formations in Blender in the future. And thank you for watching.